there, CNCers! Have I got a treat for you with this video? You've been asking for it. Get ready to see the alt mill hooked up to the vortex for this project. Oh, and I'm going to teach you how to do an epic rotary project with them hooked up too. Let's go! I'm trying to keep my cool here, but I'm not gonna lie, it's pretty hard to contain my excitement. Why, you ask? The main reason for making this video is because we were invited by Vectric to present at their yearly user group meeting in Texas. We tossed around some ideas for topics, but ultimately, we decided on presenting a rotary project and showing how to use some really cool, lesser known techniques. With the level and amount of information we are going to share at the UGM, we thought it would be a good idea for people to be able to watch a recap when they get home, just in case they missed any details, more than likely. And thus the 2-for-1 video was born. A super informative in-person presentation at the UGM and a tutorial video for those who want to learn about all these fun techniques. So what is the actual project going to be? We are going to create an absolutely epic 60-inch long, 3-inch in diameter, 2-piece dragon-headed walking stick complete with scales. Woo! I can show you if you want. Look at this thing. It just keeps going. There you go. So we got the who, what, where, and why. Now let's talk about the how. I figured the walking stick was gonna draw some attention and I'd be feeling all Gandalf-y, walking around the UGM, talking with different people about it. Speaking of Gandalf, did you notice who the dragon's head is on the top of this thing? If you didn't, it's Smaug from The Hobbit. Sorry, nerdy ADHD movie moment. Stay on track. You shall not pass! My original plan was to model the entire walking stick in a third-party software and then import it to show how to rotary carve it. I do have a pretty extensive artsy 3D background in my previous life, so that software typically is my default. But then I thought, we're presenting at a Vectric UGM. I gotta do better than just importing a model and carving it. So I challenged myself to see how much of the project I could create solely within Vectric software. The design process for this was an unexpected journey. It took me a while to sift through all the chaos in my brain to make the project something functional and digestible. I thought about having the dragon head on way more of like an angle, almost like an upside down L, but I wanted the dragon head and the top half of the stick to be one solid piece of wood. I didn't like the idea of attaching 2 separate pieces to make that happen, so I scrapped that. I tossed around having a full dragon body wrapping around the entire walking stick, you know, arms and legs and tail and all. But that was going to take away from how much I could actually create within Aspire itself, so that was out the door too. Then the whole dragon walking stick idea got leveled up hard when Jay and I were chatting one day after work, and we agreed that carving an homage, if you will, to Vectric would be absolutely sick. Sorry. I'm not going to leak what we came up with just yet. You'll have to wait and see what we worked into the design for that little goodie. Then it was just a matter of figuring out how to piece all these pieces together, you know? It'll be easy peasy, right? Wrong. There were definitely some bumps along this particular road. But let's be like really real here. Some of the methods I'm about to show you are not your run-of-the-mill techniques. So grab a snack or maybe a whole meal. Put on some comfies. Heck, get a pillow and let's get this project started. Let's start off with my material for the project. In order to make this walking stick fit on the vortex, but more importantly so that it would fit in my suitcase for the UGM, I carved it in 2 30-inch sections. I'll be using these meaty pieces of maple. I've got them cut to 3-inch by 3-inch by about 34 inches long, which gives me room to add tabs at each end to secure them. I'm using just 2 bits to crank out this entire project. CNC's 1/4" downcut to rotary surface, and CNC's 1/4" tapered ball nose for all the details. And I'll be using the alt mill to spin the vortex around to bring this beauty to life. I think you'll be pleasantly surprised by how fast I had this combo moving. Next up, the process for rotary surfacing is something we've covered in lots of other videos, so if you're not sure how to do that, check out any of the Vortex videos on YouTube to get you there. The same methods apply from toothpicks to totem poles. Are you really ready to dive into Aspire now? Let's go. The long and the short for creating the base of the walking stick is this. We're going to create one component that's got some wiggle to it using the extrude component function. Then we're going to create another component that's got some wiggle to it using the 2-rail sweep function. Then we're going to tell the first wiggly component to follow the wiggle of the second component to morph it in kind of a helical modical thingy. That's right, I said modical. Everyone with me so far? It's okay if you're not with me. Believe me, I felt the same way while I was figuring this all out many times. And lastly, we're going to export that helical modical thingy to an STL, which will be used as the base for our full walking stick. I do want to clarify that I purchased the dragon head model online that I'll be using for this project. I'd love to say that I modeled it, but ain't nobody got time for that. The walking stick components need to be created in a double-sided document so we can create the top side and then mirror it to the bottom. So the document setup is as follows. Double-sided, 60 inches long because that's how long I want the entire walking stick to be, even though I'm going to cut it in half to do the actual rotary. 10 inches tall. My rough stock diameter is 3 inches, so I'll make my material 1.5 on each side, so I'll get 3 inches total. The rest of the file settings are your preference, so set them up to what you like to do and let's keep going. I've obviously worked through the kinks for my particular project, so you may have to do the same for yours if it's got any differences. I'm dropping some guides in as references. One guide at 7 inch for where the approximate size of the dragon head model will go once I add it. Another at 30 inches, which will be the midway point of the finished walking stick, and one at the middle of the document horizontally, so 5 inches in my case, which I'll explain why right now. The first thing we'll need to do is to create a squiggly line. But before we draw the squiggle, we need to talk about undercuts. For those who don't know, an undercut basically means an area with 3-axis rotary projects that the bit just can't get into because of the constraints of 3-axis carving. One of these undercut areas would be if you cut past the center axis of your project. This factors in when we draw our squiggle and when we import the dragon head. You want to be aware of how far you push the squiggle so that it stays above the center axis, which is why I drew the initial guideline across the midline of the document. If you don't fully understand, keep following along and I'll show you what this all means shortly. And even though you're armed with all of this info, there's still a chance that we create these components and still have to come back and tweak them. But at least you'll understand the how and the why. We're going to use the draw line tool and create a wiggly line. Because I know I'm adding the dragon head to the top of the walking stick, I'm going to leave some space to incorporate that element later. My experiment showed me that it was easier to make minor adjustments than major ones when we import the walking stick model later. Adjust the spacing and the beziers to your heart's content. Next, we're going to draw 2 circles, one for the top of the walking stick and one for the bottom. My material for the walking stick will start out at 3 inches in diameter, so I'll make the top circle about 2.5 in diameter and the bottom one 1.5. These should give me a pretty good walking stick feel. I don't even know what that means. These circles are a big factor in whether or not an undercut will occur. The diameter of the circles will dictate whether or not the model drops below that center axis. So that's something to factor in when you're creating these setup lines. The circle creation locations don't matter, so create or move them wherever you'd like to. Enter into edit node mode, and when you see the little squiggle, type D to delete the spans. Now we'll create the first component using the extrude component function. We're going to tell Aspire to extrude the half circles along the wiggly line and blend them together along the way. We're basically creating like a tunnel shape. I like having my windows in split view for this so I can see what's going on. Grab your wiggly line and click Use Selection. That's my center line rail. The arrows show the direction it's being created in, so if you want them reversed, right-click and reverse rail. Then grab your larger circle. You'll see a little check mark pop up when it's in a spot where you can attach it to the line. I'll select the top of the walking stick with this one, and then do the same for the smaller circle at the bottom. You'll see corresponding color nodes for where each cross-section's start location is. I'll leave both square corners and sweep spans off. Neither of these will factor into the shape we're creating this time around. Sweep between spans can help control the shape outcome when using different shaped cross-sections, as long as I have the same number of nodes, so have some fun with that when you experiment. I'm not weaving anything this time, so that's off. Scale to height is off because the circles we created are dictating the height. I'll name the component top front stick shape. Click apply, and ba-bam, you've got yourself 1/2 of a walking stick. This is the first chance you'll have to see if there are any undercuts going on, so let's have a look. You can see no part of the newly created component goes past that center axis, so I think we're good to continue. If you did see a part that looked a little sus, just delete the component, tweak the lines, and recreate until you've got it nailed down. The 3D view is currently only showing what's on the top side. If we toggle both sides on, nothing will happen because there's nothing on the bottom side. Yet. Let's put something back there. Right-click on the top side stick shape component and select Copy to Other Side. You'll see now the top side component mirrored on the bottom, and it's starting to look like a wonky walking stick. I will rename the mirrored component to Bottom Back. My issue now is that there's only wonk in one axis. I really want it to be wonky in 2 axes. Axes. We still haven't determined what the right pronunciation is. There's just not enough wiggle all around for me. So let's create the second wiggle component that will add some wiggle to the first one. In my 2D view, I'm going to use the same wiggly line we used already. I'll create one vertical line on the left, then Ctrl-Shift-H to create a copy horizontally on the opposite side of the document. Ctrl-Shift-V will create a copy on the opposite side vertically. Select 2 rail sweep. Select the 2 straight lines and use a selection. These will be the drive rails this time. You can single select these to change the order, but that doesn't matter for what we're doing here. Select the cross section, the wiggly line we already created. Same as the first extrude we did, I'll leave all the options off. I'll bring my split view back up so you can see the magic happen. I'll rename this component to Wonky Component Top. As soon as I click apply, you'll see it create a second component that will automatically force the first component to bend to it. Ta-da! Super cool! Here's the newly created wonky component. Here's my original walking stick-ish component. But clearly this doesn't look like a walking stick. It's actually really simple to finish this whole thing off. Select the wonky top component, right-click, copy to other side. I will rename to attempt to keep myself organized. You can see in the bottom view I have a mirror of what's going on the top. The issue is, when I toggle on show both sides, you end up with this weird looking hourglass sort of something or other, but not a helical walking stick that I'm after. It's all good. Right click on your bottom side wonky component, change the combine mode to subtract, and enjoy the magic. So instead of using an additive combine mode, the wonky component is now subtracting to create the shape we want. Boom! One walking stick looking very walking stickly. We've got wiggle in both top and front axes, which is exactly what I was after. With the exception of these flappy looking wingy thingies. That's just leftover bits from the wonky components we were using. The problem is, if you export this shape as an STL right now, those flaps will export as well, and that's not gonna work. Simple solution, again, we'll adjust the base height on the bottom wonky component. In this case, if we bump the base height to 0.01, it will basically erase the leftover flappy bits, and we're left with this beautiful helical 60-inch walking stick. And the best part of this? Now you know how to create some pretty uniquely shaped models directly in Aspire using different methods. You don't need a third-party software like Fusion, Onshape, or Rhino. The last step is to export this model as an STL. Easy peasy, go to the modeling menu, export as STL. I turned my tolerance to 0.002 so the model was extra smooth. These first 3 options will not export what we're looking for. It'll do some weird stuff. So select the last option, hit triangulate, and save triangulation. Okay, so that was a lot of information. I hear you. If you need a break, you probably need a break. I don't blame you. Hit pause, grab a coffee, go for a walk, take a breath, refresh. Now that we've got the base stick exported, let's create the actual walking stick itself. Create a new rotary file that's 30 inches long, not 34 like the actual material is. There is a reason for this. 1, 3D models will automatically get cropped to the job size, so it doesn't really matter if they're too long. 2, it's going to make it easier to set up the job so the 2 halves will join up properly when the time comes. I'm going to make the job dimensions longer, but not until after we've done the modeling work. Trust me, it'll all make sense soon, I promise. 3-inch diameter. The rest are the usual rotary settings, so make sure that they're clicked properly and we'll keep rolling. Now we're going to import the dragon head model. I want to leave the weakest part of the carve to the last if I can. If you carve the weak part first, clearly you risk the entire project not surviving because of the forces on the weak part during the rest of the carve. Whereas, if you leave the weakest part until close to or the end, your chances of success go up. The dragon head here is a great example. Where the snout meets the tab that we'll add later, it's the weak point of the carve. I'll be using climb carving to minimize vibration, so I'll have to change the orientation of the dragon snout to the left to leave it to the end of the carve. I'm going to talk more specifically about the cutting direction a little later when I get to the toolpath portion of the project. Now that you know that, let's run through some settings. Initial orientation, right, so he's facing left. Interactive model rotation on X until it's more or less, vertical and centered, because right now it's kind of weird looking. Scale, I made this 2.9 so it fits just inside my 3-inch stock, which I'm gonna have to redo in a second. And then rotate on Y so the red center axis is hidden inside the model. Then I rescaled to 2.9 again and hit OK. Now I'll import the walking stick itself. I rotated the model 180 degrees so the larger diameter side was on the left to match up to the dragon head. I also scaled my walking stick non-uniformly. I made it 2.5 inches in diameter, and I'm going to make the length 56 just to make the math easier. Write down your import scale dimensions, you might need them later. Another thing to remember is that by changing the order of the components in the component stack, you can achieve different results. So give it a try if you're feeling frisky. I'll move the dragon head over to 0 on X so that it's at the very top of my walking stick. Using the transform tool, I'll get the walking stick and I'm going to change the pivot to bottom left and move the walking stick over to 4.75 inches. You can see pretty plainly the dragon head and the walking stick don't blend together seamlessly. I could try and scale both up or down to get them closer, but the reality is it just needs a little more finessing. This is again where the higher end modeling tools within Aspire come in super handy. I'm going to use the Sculpt Visible Model tool to blend the two models together a little more seamlessly. I use the remove option to obviously remove some of the dragon neck that was a little unsightly. I selected the walking stick portion and used deposit to build up some of the low areas. And finally, I used the smooth option to go in and create a fairly smooth transition between the two components. You can paint in wrapped or unwrapped modes by clicking on this little cylinder icon right here. Painting in wrapped mode is super handy because you can see exactly how the changes interact, but can take a little practice to master because it paints as though it's still unwrapped. So now you just sculpt the models until the transition between them looks, a little bit better. And depending on how picky you're going to be and who you are, this could take a little while to really get it dialed in. Don't forget to change around the size settings for the brushes too. You've got some amazing controls available, so try them all out and see how they work. You can always undo or remove by painting areas if you don't like what result you're getting. A huge note here. Once you've applied sculpting changes to a model, you've basically baked the changes into the model. It will crop it to the job size and you will lose the ability to re-import it. Super important. This looks great, but you can't have a dragon without scales, so let's add those. I've got a little tributary trick up my sleeve for these. Scales on most creatures that have them are kind of a roundish V shape, right? It just so happens the fine folks hosting this user group meeting have something in common. No, they don't have scales. Not that I know of. Come on, people! I mean, their logo is a roundish V shape. So we're going to use the Vectric V to make the scales for our dragon walking stick. I've got the Vectric V in vector format here, so I'm going to import it. I experimented with a few options to get the pattern to look its best. You can create a pattern with vectors and use a pocket toolpath. You can create a pattern with vectors and create components, or you can create a textured area component. I found that no matter which method I chose, the pattern would get a little squashed and stretched when it was applied. This is unfortunately because the surface of the model isn't flat, and therefore the scales kind of stretch and squash with the shape of the model. I'm going to show Becky how I do this in another software so there's no distortion, and if Vectric thinks it's important enough, maybe they'll spend some time tweaking their settings. Ultimately, I found creating the pattern with a group of vectors turned into a flat component netted the best results. So grab your vector. The size doesn't really matter right now, you can always scale it down later. Use the Array Copy tool, and here's what settings worked for my project. The rows and columns are going to equal as many as you need to cover your model size. You'll probably need to experiment with these numbers. Offset selected equals the same dimensions as your X and Y object size. Symmetry I had as L shapes. The row and column displacement equaled half of your X or Y object size, depending on which orientation you want the pattern to be repeated. In my case, I'll enter in half of my Y value under my Y displacement, hit copy, and voila! The Vectric V scale pattern is born. It's so majestic. I purposely made the array larger than I needed to for the top, but that's only because I know from experimentation that I'll need more on the bottom side when the time comes. I also made sure I offset the scales pattern so that it lines up with the two halves where they wrap around, so the V's aren't cut off and doing something weird. With all the pattern vectors selected, choose Create a Flat Shape Component. Rename, then change your base height to whatever you'd like. If you want to check on the fade or tilt, if you'd like them, go for it. I'm not going to. Hit Create. Now you've got a scales pattern component that will follow the shape of your walking stick. You can still move this component around as well if you'd like to. I'm going to move the scales down in the component stack so they're underneath the dragon head, and ta-da! This looks so much better than when I started. We need to add some tabs to hold everything in place. But first, I'll need to make the file size larger like I talked about way back in the beginning. I'm going to make it 34 inches just like my material and leave everything else as is. The great part of creating this way is that the 3D model got automatically cropped to the correct size, so that's already done. I know by adding 4 inches to the length that I have 2 inches on both ends, so I'll select everything and move it over by 2 inches. Grab a 3D tab from the clip art menu, scale it up to fill the blank space, but leave a blank space right at the snout there. You'll see why in a second. Holding Alt allows you to free transform the tabs. I'll rename and change the base height to 1.5 so it's the same-ish diameter as my material. Just be careful not to make them too big, otherwise you'll get a warning when you go to do your toolpaths. Now I'll copy, rename, and make another tab just a little bit smaller, a little more sturdier, close to the size of the dragon snout. It should make cutting the tabs free a little bit easier. Select both tabs, Ctrl-Shift-H to make a horizontal copy. I'll adjust their placement to contact the model, and the top of the walking stick is basically ready to go. Now that we've got the top half of the stick figured out, let's get the bottom done. The whole model's overlapping thing makes this a little tricky, but I think I figured out a pretty simple way to show you. Create a new sheet, rename, and activate it. If you didn't use any sculpting tools on the top half of the walking stick, then you can just copy that component to the new sheet and ignore this next part. If you did do any sculpting for the model on the top half, you'll have to re-import your walking stick model. See why I said to write down your settings? Import the walking stick on the new sheet. Change the settings to match what you did the first time you imported it. If you don't remember, I rotated mine 180, I unlocked the ratio, and I made it 2.5 inches in diameter and 56 inches long. Just like pretty much everything, there are other ways to figure out the leftovers, but this is the way that I used. Each section of the walking stick is going to be 30 inches long. If we take 30 inches and subtract how far we moved the walking stick over by for the top half, 4.75 inches, that equals 25.25 inches. That's how much of the original 56-inch walking stick we actually used, which means 56 inches for the original walking stick minus 25.25, the amount that we used for the top half, equals 30.75 inches. So that's how much of the newly imported walking stick we need to keep. Select the 3D model, go to Transform, change the position to bottom left, and move it over to 0. Then we can create a rectangle that's the size of the portion of the walking stick that we need, so 30.75 inches. We're going to place it at 25.25 inches to help us move the model into place. Now we have the portion of the walking stick we need to carve right where it needs to be sliced to line up to the top portion of the walking stick. When I did my first test, it wasn't this meticulous, and let's just say it didn't turn out. That's why I did this. Now I'll copy the rest of the components and tabs that we can recycle to the new sheet. Unfortunately, I did redo the array on the V's so they filled the bottom length. I thought I had it right when I did the top, but clearly I didn't. I'll also adjust the tabs as needed so that they are contacting the model and the correct diameter. To hopefully make life easier, I'm adding some registration marks to the end of each of the walking stick where they're going to connect together. I'll create a really tiny rectangle that I'll turn into a flat component, just like we did with the Vectric V's, that I'll center on the middle end of the bottom. I'm going to copy that component to the other sheet and slide it down to the middle where they're going to connect, and fingers crossed that we end up with a little mark showing us where the two halves should line up when we twist it together. And last but certainly not least, we gotta make some toolpaths. It's going to be the same process for the top and the bottom, so I'm only gonna do it once. I've done quite a few rotary experiments and have yet to see a 3D finished toolpath carve faster than the spiral layout version. And because they're very simple to set up, that's what I'm gonna roll with. Go up to Gadgets, then Wrapping, and Spiral Layout. We only need to touch 3 settings to make this work. Strands, 1. Done. 0.00625 for spacing between strands. This is basically the same as setting your step over within your bit settings. The formula for it reads like this. 0.0625 inch tapered ball nose multiplied by a 10% step over equals 0.00625 spacing between strands. And lastly, the twist direction is something I reached out to Vectric about. Your toolpath direction and the rotation of the stock dictate climb or conventional cutting. That basically means the bit is pushing the material away as it's cutting, or it's pulling it in. There are times and places for both, but for this project, because of the length of the material, without any support in the middle, I wanted the bit to pull the wood towards it, climb cutting, to minimize vibrations caused and reduce the chance for breaking. In order to achieve this, I'll be cutting right to left. Right to left? Whatever right to left is to you guys, right to left. So I'll use right hand twist. It'll take a minute to calculate. You can see when it's done that it's created a vector that will be the continuous toolpath. There is one tweak we need to make to this vector though to make it cut absolutely efficiently. Select the vector, use the transform function, set the pivot to bottom right, and change the Y value to 0. You'll see the vector move to the right side of your model. This doesn't change anything about it other than removing basically a whole bunch of unnecessary air carving, we'll call it. Now we can add a profile toolpath to the vector. Cut depth of 0 as it told us to do in the spiral layout instructions. Select your bit. I'm using a 16th inch tapered ball nose to get lots of detail. I wanted to see how fast I could get this thing to run, so I'm going big. Speed 600 inches per minute, plunge 300 inches per minute. Make sure the machine vector is set to on, add ramps if you choose to. And here's a whole nother chapter to this cutting direction thing. Todd and Edward pointed out that you can also mess with the Start At tab where you can select where to start the toolpath from. This is another control you can use to change the cutting direction depending on what you have selected. I'll be straight with you guys, I didn't have time to do actual cut experiments with all the different options and settings that were here. What I found worked for me was leaving it at move to start points. Again, I didn't have time to save each option, to carve them out, to see how they actually worked and which direction they went. So if you're experimenting and you find a method that works really well, please make sure you share that on the socials. Super important to make sure that you have project toolpath onto 3D model, otherwise that spiral won't wrap around your walking stick and you'll get nothing. Rename, calculate, which might take a minute or two. Save your toolpaths, load them in G-Sender, and let's finally get this walking stick running. There wasn't anything particularly groundbreaking that I used to finish the walking stick. I was extra careful when I cut the tabs off because I didn't want to mess with the Vectric B scale, so I left myself a little bit of extra and sanded it off. I'd recommend cutting the middle tabs off first because you've got the outside tabs to help you kind of line everything up better on your saw. You can't exactly sand this thing with the 6-inch random orbit sander. So I spent a good chunk of time with sandpaper and some tools getting into all those nooks and crannies. This rotary type tool with these fine sanding stars and spongy pad things did a pretty good job of getting rid of any fuzzies or slight imperfections that were left. And then it was just a matter of getting in there with some sandpaper to, really refine it the way I wanted it. Other than that, I gave it a bath with a wood protecting product like Ligna or Rubio, and that was really all there was to finishing. Alright, so now I'd like to share the part of the project that gave me absolute fits and nightmares. I can't believe how badly this little simple thing tripped me up. These stupid little threaded connectors. I thought the rest of the project was pretty tricky until I tried to come up with a foolproof, teachable, repeatable way to drill plumb and square holes in a helix. That was a mouthful. I built jigs and guides, I used hole saws, I tried my drill press thinking it would eliminate some variables, which I'm sure it did, but I think it also created new ones at the same time. I'll level with you. I tried to science and math and theory my way through this, and I failed miserably. The holes on the first attempt were off center so bad, they didn't even come close to aligning when it was screwed together. It's a good thing though that I'm an expert at fixing mistakes. So I took a couple deep breaths while the super glue was drying around the plugs that I made, and then I kind of went back to what I knew. I redid finding center the old way I know using a set square. The center finder tool will work fantastic for normal cylindrical objects, but the textured surface, the variable surface, gave mine inaccurate locations. Once I had what appeared to be fairly true centers found, I started with a small drill bit and gradually just made the holes bigger until the connectors fit the way they should. Some thickness super glue should hold these rock solid, I hope. I will suggest gluing one end of the connector in first and letting it dry. Then thread the second half of the connector onto the first, add glue to the hole without the connector, and slide the connector into the hole. Push the two halves together until they are flush in the middle and meet. Then twist the wet glue side until the registration marks the line. I will be the first to say I'm not thrilled that this was my method for drilling these out. I take pride in my ability to figure out how weird things work and to make them work. But this fiasco did help remind me about a few important things. One, it reminded me to stay humble, which I already kind of think I am, but this just reminded me yet again, there is always something new to learn out there. Two, it reminded me to be honest about my struggles and to show them to everyone watching. I know someone out there watching has a way to do this and we can learn from them, which opens the door for people meeting new people, which is where all kinds of amazing collaborations and relationships can start from. I think that that's a pretty amazing byproduct of one person being honest about not knowing how to do something. And three, sometimes tried and true is tried and true for a reason, but good for me for trying. So what do you think? Pretty epic, eh? I think so. It's still fun for me when I do a project and I struggle and I'm surprised by how nice it turned out. I don't know. Do you think I should go 2 videos in a row and see if I can get Sir Ian McKellen to give us a shout out?
I have not passed through fire and death to bandy crooked words with a witless worm.
I really hope you enjoyed this video and learning some fun new techniques to try out. I am well aware that there is a ton of info in here, so if I didn't explain something fully enough or clearly enough, or if you'd like some more info, please, drop your question in the comments below and we'll do our best to answer. As always, we appreciate that you spend your time watching our video. We absolutely love making cool products and awesome videos for you guys, so be sure to spread the good word about CNC so everyone can experience the awesomeness. Until the next epic carve, we'll see you around the CNC.